All right, so I'm going to go through these problems here for this exit slip, which you guys did at the beginning of class this time because we ran out of time to class before. But I'm going to go through these, so in case you didn't do very well on it, watch this video and go through it and look to see where you made your mistakes. What some of you is you didn't follow this direction of writing all of your answers as positive exponents. So make sure that you are writing all of your answers as positive exponents. All right, so for this first problem, we have 3 times a to the 7th, b to the 8th, over top of a to the 4th and b squared, all being raised to the 3rd power. What I like to do first is when I have these parentheses, because of our PEMDAS, the parentheses does occur before our exponent, even though we could distribute that exponent in. So I'm going to simplify everything I can in my parentheses first. So I see I have a and b is my numerator and denominator. Well, my rule is I subtract. So it becomes 3, and then 7 minus 4 is going to be equal to 3. So since I had more a's in my numerator, I know it's going to be 3a to the 3rd power. And then 8 minus 2 is going to give me 6. I have more b's in my numerator, so I know that my answer is going to leave with that b to the 6 in my numerator as well. So now I simplified everything that I could, and then I'm going to go my power to a power. And remember, our power to a power, we multiply. What some of you are doing is you're doing 3 times 3 and saying that this answer is 9. That's not correct. We're not multiplying the base with the power. We're multiplying our power with the power. And this 3 is understood to have a power of 1. So this 3 can now be rewritten as 3 cubed because we multiplied 1 times 3. A is now a to the 9th, 3 times 3. And b is now b to the 18th. Then the last thing we need to do is we actually are going to be cubing these numbers now or squaring them. And 3 cubed is 27. So our final answer is 27, a to the 9th, b to the 18th. All right, so for this one, we have x to the negative 12 power raised to the 3rd power. Now, there's different ways we can do this. You could simplify if you want your inside your parentheses first. I'm just going to go ahead and multiply these together first. We know our rule is we multiply power to a power, so it's just going to be equal to negative 36. So now I have x to the negative 36 power. However, we cannot leave it with a negative exponent. They all need to be positive. So since this was in our numerator, we would then flip it and take its reciprocal and move it to our denominator. So it will be 1 over x to the 36 power. All right, and here we have 2x to the 4th raised to 0 power. All of this is in the parentheses. So all of it is being raised to 0 power. Anything raised to 0 power is 1. So our final answer for this is just simply 1. Because all of it was being raised to the 0 power. If it said 2x to the 4th raised to 0, something like this, then yeah, only the x is being raised to 0 power, and this would become 2 times 1 or 2. But in this problem, all of it is being raised to 0 power, so our final answer is just 1. All right, now for this problem, there's no powers, no exponents that are outside these parentheses, so we're simply just multiplying them together. So we multiply our likes with our likes, meaning our coefficients we multiply. So 6 times 3 gives me 18. And now when we multiply our like bases, when we multiply, we add our powers. So 2 plus 5 is equal to 7, so it becomes a to the 7th. And then our b's, well, we have an 8 and 10, so we are adding them together to get 18, so it is b to the 18th. And this is our final answer. Right? There's nothing else that we can that we need to do with this, and there's nothing else that we can do. But just make sure that when we're multiplying, we're adding our powers of our like bases. All right, so for this problem here, what I would suggest that you actually do first is let's get rid of that negative power of 2. And if I gave you a problem of 1 squared raised to the negative 2nd power, well, if you were to try and do this, or forget this 1/2 squared, let's do something else first. Let's just say 2 to the negative 2nd power. Well, when it's in our numerator, we know we can rewrite it as we take its reciprocal. We flip it to that denominator. If it's 1 over 2 to the negative 2nd power, well, we can then take its reciprocal and move it to the numerator. So when we're getting rid of those negative exponents, we're taking the reciprocal. And the reciprocal means we just are flipping those fractions. So if this is 1/2 to the negative 2 power, we can think about this as 2 to the positive 2 power, because by taking this reciprocal and rewriting it as 2 over 1, which we don't have to write over the 1, that then changes this power from a negative to a positive. So when we're dealing with a negative power like that, especially when it's a fraction that the whole thing is being raised to, we can then take the reciprocal of that fraction and rewrite it as 3y cubed over 2x squared. And now since we took the reciprocal, that negative 2 power is now a positive 2. And remember, this is getting distributed to all the powers that we have. Some of you are still doing 3 times 2 to get 6, but this is now saying 3 squared, because that has a power of 1, and 1 times 2 is 2. And then this becomes y to the 6th. 3 times 2 is 6. This is now over 2 squared. The power of 1 times 2, so it's 2, and x to the 4th because we now are doing 2 times 2, which is 4. But since we can actually do 3 squared, which is 9, and we can actually, do 2 squared, which is 4, you must write your answer like this. All right, let's move on to the next one. All right, so for this one, same thing as we did with the multiplying a few problems ago. This is all just straight dividing. So we will then take that 10 over 8 and we will just treat it like it's its own fraction. And how would that reduce? Well, 2 goes into 10 5 times and 2 goes into 4. It goes into 8 4 times. So I know that my fraction is at least going to be 5 over 4. And then we're going to go through each of our variables. Well, we have 9 x's in our numerator and 4 in our denominator, so we can do 9 minus 4, which is going to give me 5. And since I had more x's in my numerator, I know that it's going to end in my numerator as well, so it's x to the 5th power. Then when I go on to do my y's, well, I see I have more y's in my denominator. And one of the things I told you is we can always just make sure we do the largest minus the smaller. And then just think about where do we have more? Because 7 minus 10 is equal to negative 3, and 10 minus 7 is positive 3. But since some people forget to get rid of the negative exponents, I always just say, okay, do the larger minus the smaller, and then just ask yourself, where was there more variables to begin with? There was more in our denominator, so my answer is going to go in my denominator, so it will then be y cubed in my denominator. So this will be my final answer. I simplified the coefficients, and then I did my rule of subtraction with my variable x and y, and then each time I'm asking, where was there more to begin with, and that's where my answer will be. All right, so that's one of the ways that we can do this. If you think it's a little bit easier for you, by all means. If not, you don't need to do it that way. All right, once again, this problem you actually can do a few different ways. I'm going to explain how I do it. Because I do it this way, that's not how you have to do it. But when we're doing this, we can't multiply these two parentheses first because we see that we have the square. An exponent comes before multiplication, so I must do this exponent first. All right, so that means I'm going to distribute this power 2 to everything. You could get rid of that negative first if you wanted to, but since I look over here and I see that I have a lot of x's that I'm going to eventually be multiplying it to, I'm not going to move anything with that negative just yet because I'm hoping that when I multiply, it's going to turn positive anyway. So now I'm left with 3 to the 2nd power times x to the negative 10, because power to a power we multiply, times y to the 8th, and that's all still being multiplied to 6x to the 18th, y to the 7th. And now I'm just going to go ahead before I multiply these, I'm going to square that 3, which is 9. And now, as I'm doing this, well, I know my rules when I'm multiplying with like bases, I add them together. So the first thing I'll do is I'll multiply my coefficients, and 9 times 6 will give me 54. Then I'm going to move on. Well, now what my x's, it's negative 10 plus 18, which is equal to 8. I'm adding them together. So this is then going to give me x to the 8th power. So because there were more x's I was multiplying with in that second parentheses, I didn't have to worry about flipping any negatives or doing anything like that because it turned into a positive power for me anyway. So then from here, we are going to add, which is then going to give me 15. So it gives me y to the 15th. And that will be our final answer. All right, so for here we have 2a to the 5th power raised to the 4th power. So remember, everything needs to be raised as power of 4. So this has a power that's understood to be 1. So it becomes 2 to the 1 times 4 power, or 2 to the 4th power. Then we will multiply this 5 and 4 to get a to the 20th. But like I said before, we're no longer leaving our numbers as a base raised to a power. We'll actually multiply that. And 2 to the 4th power is 16. So it's 16 times a to the 20th power. All right, and then our last problem is we're straight just multiplying across. So we'll multiply our likes with our likes, so our coefficients with each other. So 8 times 11 is 88. Then I'll multiply my variable x's. So I'm just adding those powers, which is going to give me 11. So x to the 11th. And then I'm just going to just multiply and add my y's together as well, which is then going to give me y to the 15th. All right, that will be our final answer. In this worksheet, or in this sheet that you handed in, question number 7 would be considered a mastery type question for now. So that's one that if you struggle with that one, it's all right. That's one that's more mastery. But all the rest of these you would need to be able to do in order to be proficient, or at least be able to do a majority of them in order to be proficient. All right, but that is it for this video.